Thank you for your question regarding the percent problems on the College Readiness Math MOOC. Hopefully I can help with some of your questions through a podcast rather than typing up the solutions. So your first question was about the tip question. And we were looking at a restaurant bill. And we know that our total bill, including the tip, was $70.50, which we know that we'd have the bill plus the tip amount. That should equal our $70.50. Now, if we just knew the bill, we could find this result pretty easily to find the total bill because we would use your strategy. So if I went to a restaurant and my bill, well, we'll just use the answer, was $59.75. I'd add on the tip, which we know that we can calculate by taking 18% of our bill, and that should get the total amount that I paid. And we can actually check to see that we're correct. So if I took $59.75 and then I added it to 18% of $59.75, I'd realize that my tip is about $10.75, or if you round it up, $10.76. So when I added my two values together, $59.75 and $10.75, I would indeed get a total bill of $70.50. So now that we're given the total bill, I almost have to work backwards in order to figure out what the real bill was without the tip. So if I didn't know that, I could actually set up an equation, if you like equations better. This is how I kind of think through it in my head. I have my bill, I'm just going to call it B, plus my tip. Now, we found our tip by taking 0.18 times our bill, or 18% of our bill. So in algebra, I'd write that as 0.18 times our bill, and that was equal to $70.55, or $70.50, sorry about that. Now, if I look at my left-hand side, I'm just going to kind of combine my variables or combine my like terms. I have 1b plus 0.18b, or if I add 1 plus 0.18, I'd get 1.18 times my bill is equal to $70.50. What this really means is that my final bill is 1.18 times as much as my bill without gratuity, right? So now if I'm going to solve my equation, let's rewrite it up here. I want to undo multiplication, and to undo multiplication, I'm going to divide both sides by 1.18. And if I take $70.50 divided by 1.18, I will see I will get about $59.75. Now these percent markups, I'm actually marking up my original bill. That's why we call them a percent markup. And the other questions that you saw, percent decrease, where I actually take off a discount, can all kind of be set up in the same manner. So now if we looked at this, why I know I have 1.18 is because really I'm paying 100% of my bill, right? I have to pay that, plus an additional 18% of my bill. So literally I'm paying 118% of my bill when I include my tax. And if I want to change 118% into a decimal, I know that it's represented as 1.18. So 118% of my bill is the same as multiplying my bill by 1.18. So let's just take a journey on these kind of general percent increase, percent decrease tasks. So let's look at our percent increase just in general, right? So there's kind of three parts to a percent increase. I need to know my original amount. In that case, it was our bill without tax. It could also be the cost of something. So kind of the original, our starting price. I need to know my percent increase. And then I need to know my final amount. And in this case, our final amount was the bill with the tax, or the $70.50. So if I kind of put the pieces together, suppose I had, we'll just go with a 20% increase. Right, so suppose instead of giving 18% tip, I get a 20% tip. Or if I go to the store, they typically mark up what they pay for it by a certain percent. So my general ideas are, I'm always going to take my original, I'm going to add on the amount of percent increase. Right, and I find that by taking my percent increase, let's say 20% as a decimal, times my original, and that should always give me my final amount. Right? And so our case, we had our bill without tip plus our tip is equal to that final cost that I paid when I walked out of the restaurant. So if I think about this, if I had some variables and I let x be my original cost, then I'd have x plus 0.2x is equal to my final. Or if I added them together, I would see that I get 1.2x is equal to my final. This is because I'm paying 120% of my original cost. So notice I can kind of simplify the process by, if I have a percent increase or a markup, I'm just going to take 100% plus that percent markup, and that becomes the value that I'm multiplying to my original price. Now I can even take a quicker shortcut, because notice I'm now going to divide both sides by 1.2. So x, my original price, is always going to be that final price divided by 1.2, which represents that markup. Now I know that when I divide a number by something greater than 1, it actually makes that final price smaller, which makes sense because my original price has to be less than my final price if I have a percent increase. Percent decreases are going to be kind of the same way. So let's look at some of the self-check items that you are are asked a question about. So I'm going to go back to our tip one. So you make a checkout for $168 for your lawn care company. If the amount of the check includes a 15% tip for the workers, I want to know how much the bill was before the tip was added. Well, now I know I have this percent increase. And I can't merely take 15% of 168 because this is not equal to the tip. I know that my bill was less than $168. So if I took a 15% of 168, I'd actually be paying more tip than when my bill was, well, we know the answer, $146 about, right? So I need to figure out kind of what was that original bill. Again, if I go back, I can think of if my bill before the tip, let's call it X, plus my tip, and we know we're going to take 15% times X, that total gave me $168. So notice with that percent increase, I'm going to pay 1.15 times my original amount is going to give me 168. Or our shortcut was take the final over that percent increase, or 1.15, because we paid 115% of our original bill. And if I take 168 divided by 1.15, I should get the original bill, because that's what we said X was equal to. So if I did the same thing with my television, so a television company actually marks up all their TVs by 70% than what we pay for them. So if I walked into the television store today and I bought a TV for $525, I kind of want to know how much the electronic company actually bought the television for. And I know they bought it for a lot less than $525. So again, if I let X equal to the original price of that television, that company is going to mark it up by 70%, or 70% times X. That's going to be what I pay for it. Or if we like our shortcut, we know that if I added my two x terms together, that I have 1.7 times x is equal to what I'm paying for it. Again, couple ways to look at it. I'm paying 1.7 times as much as an electronic company, or I'm paying 170% of the original cost. And that's why you're always going to see with these percent increases that in order to find the original price, we take the final price divided by that percent with the increase, or 100% plus the percent increase, but we do it as a decimal. So if I took 525 divided by 1.7, I get 294.26. Now, just if I wanted to go back to those percent decrease tasks, let's just look at a generalization. Suppose I went in and I bought a calculator, because I have no idea what else I'd want to buy, and it was on sale, so my sale price was $60. Right, this was after I gave them a 20% off coupon. So I always want to know what was the price before the discount. So again, I can't just take 20% of the sales price, because that's going to give me a lot less of a discount, because I know the original price, or the price before the discount, was much more than 60% or $60, right? So I'm going to have to set up the same type of structure. So let's say that my price before the discount, or what we would call the original price, so my original price, and that's before the discount, minus the discount, is always going to give me to the final price. In this case, that final is my sales price. So since I don't know my original price, I'm going to call it X. We'd all go into the store, and if it was 20% off, we would all take 20% off the actual price tag, or the original price, in order to find our discount. That's going to be equal to our final price of $60. Now notice, now when I combine my variables through subtraction, I have 1 minus 0.2, or 0.8. What this means is I'm paying 80% of the original. All right, so I know I had a markdown. Oops, and I have an extra 0 on 60, so let's get rid of that one. So now, in order to find my original price, the price before the discount, I would take my final divided by 0.8. And if I did that, I would get my original price was $75. Now notice it's the same structure, and I could just, if I wanted to, go right to kind of that generalization, that if I have this percent increase, percent decrease types of tasks, I'm always going to have, so I'm going to start a new page, I'm always going to have my original, in this case my percent decrease, and then a final price. In our case, that was the sales price. So if I knew my percent decrease was, let's say now 25%, right? Then an equation that I could make is that if I wanted to know my final price, I would take my original minus my discount, and that would take me to my final price. Well, let's call our original X, and in order to find the discount, we would take 25% of that original price, or 0.25x. That gave me my final. So as you can see, with that percent decrease, when I take 1x minus 0.25x, I can see that I get 0.75x is equal to my final cost. or literally it tells me that I paid 75% of the original is the same as my final. So again, there are some different strategies, and I hope this podcast helped. Please let me know if there's anything I can do to assist you.